This is electrostatics conceptual questions, number 11 through number 20. A positive ion is an atom that has more protons than it does electrons. So remember, you can add or remove electrons. Let's say that I have an atom that has 2 protons and it has 1 electron. If it has that, then it has a +1 charge. If a different atom has 3 protons and only 2 electrons, it would also have a +1 charge. So you'll notice that the rest of these also have a +1 charge. So all of those are positive. They can have any positive number within reason, but that's typically what you'll see is more protons than electrons. For number 12, it says conservation of charge means that, and then there are 4 things we can talk about. The total amount of charge in the universe is constant. So if you had to measure all the charge in the universe, you would always come up with the same number, no matter what time it was. No experimenter, so Einstein, Newton, nobody's been able to see just a single charge destroyed all by itself. In addition, electrons by themselves can be neither created nor destroyed, so we've not been able to destroy or create electrons. And the charge can neither be created or destroyed in a system, so all those stay the same. The question that you'll see, this will be all of the answers, and that's why you see the all of the above. For number 13, if you comb your hair and the comb becomes positively charged, your hair becomes negatively charged. So we've got to transfer that charge from one thing to the other. So it's going really here from the comb and it's going to your hair. The electrons are, or the negative charges. To say that electric charge is conserved basically means there's no case that's ever been found where a net charge has been created or destroyed. So this has not happened. For number 15, there's a big difference between gravity and electrical force. Gravitational force is very weak, so this is very weak. Electrical force is very strong. It's very strong, and there's an equation that we can look at for both of these. The force of gravity is equal to a constant, which is g, times the mass of one object times the mass of a second object, all divided by the distance between them squared. And if you remember, the force of electricity, so we'll put Fe here, is equal to K times Q1, the first charge, times the second charge, all over the distance between the charges squared. The number for G, we remember, is 6.67 times 10 to the negative 11th, and the value for K is 9 times 10 to the 9th. So it's much larger than the value for the gravitational constant. Both of them act over an infinite distance. Doesn't matter how far away you are from something, it will have both an electrical and a gravitational field. They both obey the inverse square law. We know that because we see the d squared on the bottom, and that helps out. There is a separation distance, and you see that in both of those, but gravity is only attractive. It only will pull an object in. Electricity can be both attractive and repulsive. We remember that 2 opposite charges will attract, and 2 similar charges, no matter whether it's 2 protons or 2 electrons, those will repel each other. So that's number 15. For number 16 says the hydrogen atom, what's it composed of? It's basically very easy, just 1 proton, 1 electron. Remember, this is the one that does not have any neutrons. There are no neutrons in that. In a good insulator, electrons are usually tightly bound in place. If I have a piece of plastic and it's made out of carbon primarily, those electrons in carbon are really close to the carbon, so they aren't very far away. If I have a conductor, the conductor, let's say that it's copper, those electrons are going to be really far away, so we can just draw those out, and they're very easy to steal. The carbon atom, it holds on to those electrons very well, so it's typically an insulator. For number 18, objects can be charged 3 ways. One of them is by induction. That's where I get 2 things close to each other. One is friction, so if you rub your hands together. And the last one's touching, where you're not making any friction, you're just touching something, kind of like if you touch the finger to the end of the nose, same type of thing. For number 19, charge carriers in metal are electrons rather than protons. Because we know that those electrons are pretty far from the nucleus, they're very loosely bound, and we know electrons are very light. So if we go back to our copper again, the electrons are really far away from the atom, which means that they're really easy to take off, and that's where we say they're loosely bound. And we know that electrons are very, very light compared to the protons on the inside. So those are the differences between them. And then the last one is number 20. You want to be inside of a steel building instead of being inside of a wood building during a thunderstorm, because in a wood building that electricity will go into the wood. Sometimes that wood will catch fire. And in a steel building you end up with a shell, and so if it hits the top of that shell, the electricity, instead of going into the building, will actually be conducted around the outside of the building and then into the ground. And that is the end of number 11 through number 20.